In this short presentation, we will be going to discuss about nanomaterials. Nanomaterials are the materials having at least one dimension in nanometer scale range, that is, from 1 nanometer to 100 nanometer. The word nano was originated from Greek, which means dwarf. 1 nanometer can be defined as 10 raised to minus 9 meter. Examples of nanomaterials are carbon nanotube, nanoparticle, metal rubber, quantum dots, etc.
Classification of nanomaterials. Nanomaterials is classified into three types: natural nanomaterials, incidental nanomaterials, and engineered nanomaterials. Natural nanomaterials are made by nature through geochemical or mechanical processes without connection to human activity. Incidental nanomaterials are nanomaterials which are produced unintentionally as a result of human influence. Engineered nanomaterials are nanomaterials produced and designed by humans.
Classification based on materials. Carbon-based nanomaterials. Materials in which nanocomponents is carbon are called carbon-based nanomaterials. Examples are carbon nanotubes, fullerenes, graphenes, etc. Metal-based nanomaterials are made of metallic nanoparticles. Example gold, silver, metal oxide, etc. Nanocomposites are combination of nanoparticles with other nanoparticles or with larger bulk type materials. Example nano-sized clay within a bulk material.
Continuing classification based on material, the fourth one is nanodendrimers or polymers. Nano-sized polymer built from branched units. Dendrimers means are highly ordered branched polymeric molecules, and these are tree-like molecules with definite cavities. Example for nanodendrimers are polyester, triazine, peptide dendrimers, etc. Fifth one is biological nanomaterials. These nanomaterials are of biological origin. Example DNA nanoparticles, nanostructured peptides, etc.
Nanomaterials are classified on the basis of dimensions. It includes 0-dimensional, 1-dimensional, 2-dimensional, and 3-dimensional nanomaterials. All the three dimensions are at nanoscale in a 0-dimensional nanomaterials. No dimensions are at greater than 100 nanometers. It includes nanospheres and nanoclusters. Two dimensions are at nanoscale in a 1-dimensional nanomaterial. It includes nanofibers, nanotubes, nanorods, and nanowires. In a two-dimensional nanomaterial, only one dimension is at nanoscale. It includes nanofilms, nanolayers, and nanocoating. In three-dimensional nanomaterials, no dimension is at nanoscale. All the dimensions are at above 100 nanometers, and the examples are bulk nanomaterials and polycrystals.
Nanomaterials have various properties which are suitable for many applications. Due to their high surface to volume ratio, they are used in catalysis and gas sensors. Low melting temperature is useful for material processing. The next property is increasing hardness and resistivity with decreasing grain size. This is the reason behind why the nanomaterials are employed in hard coatings and protective layers, and in many fields of electronics. For batteries and hydrogen storage, we can make use of atomic transport kinetics property. Nanomaterials also have improved reliability.
The application of nanomaterials. Nanomaterials have wide range of application in our day-to-day life. The first one is drug delivery, which is the application of nanotechnology in the pharmaceutical field. And the next is biosensors, which is used for the development of immunoassays, diagnostics and biosensors for various analyses. And also in the supercapacitors for regenerative braking, short-term energy storage. The next are in the lithium-ion batteries and in the electrocatalysis and in fuel cells. In fuel cells, nanotechnology creates more efficient membranes. And the last one is in the water purification, where nanomaterials possesses important function in the removal of waterborne pathogens, toxic metals and anions. These are the application of nanotechnology.